So when we did 343, we got 7 cubed to the 2x, and 1 over 49 is 7 to the negative 2 to the negative 3x, which leaves us 7 to the 6x equals 7 to the 6x, which means that 6x equals 6x, right? And when we subtract 6x from both sides, we get 0 equals 0. So what's the answer going to be if you got a true statement? All real numbers, or infinitely many. All right? Or write it out. All real numbers. Any of those. So here we've got to leave the guy with the exponent alone. So we're going to add 4 to both sides, and we get 14 to the n minus 3 equals 66.2. Everybody see what I did? Add 4 to both sides. Now, the variable is in the exponent, so this one we need logs, because 66.2 does not translate to 14 to the anything, so we can't find the same base. So here we change it to log base 14 of 66.2 equals n minus 3. This you can put in your calculator. You're going to get an ugly decimal, and it's going to be, so it equals that ugly decimal equals n minus 3, so we add 3 to both sides, and we get that n equals 4.5889. If you go to 3 places. If you go to 4 places, it's 4.5887. Either way is fine. On the next section, no properties are required. Let me see which one I want to do. Starting at number 5 says log base 6 of b plus 9 equals log base 6 of negative 5b minus 3. So if it's log of this mess equals log of that mess, we know that this mess, b plus 9, equals negative 5b minus 3. And then it's just stupid math. So we've got 6b when we add 5b to both sides equals negative 12 when you subtract 9 from both sides. And b equals negative 2. So one more thing we have to remember to do is to check to make sure when we plug this into here and here, we don't get a negative number, okay?
Oh.
So when I have negative 2 plus 9, we're good because it's still positive. And when I have 10 minus 3, we're also good. So that is a good answer. Now we're doing number 6. Same routine. Log base 3 of that mess equals log base 3 of the other mess. That means that 3 minus 2x equals negative x minus 5. And when I move the x's to the left, I get negative x. And when I move that 3 to the right, I get negative 8. So x equals 8, right? Well, what happens when I put an 8 in here? I get negative 8 minus 5 is negative 13. When I put an 8 in here, I get 3 minus 16, which is negative 13. So it's no solution. Okay, so on this one, you look at your property sheet, and your property sheet says that when there's a negative, it can turn to division. So this turns to log base 2, 1 log.
Are we looking at the back?
Of no ln's. It's the x plus 2 over 10 equals 1. Do you see the property? It says log of something minus log of something equals log of something over something. Do you see the minus? It should be the second property. You have to change these to 1 log on the left side. So now we have a situation where we have a plain number on the right and log on the left. So you can't make x plus 2 over 10 equal to 1. You have to put it in exponential form. Which is the base is 2, the exponent is 1 equals x plus 2 over 10. So now we have all numbers, and we can just put that over 1 and cross multiply. So we have 20 equals x plus 2, and x equals 18. And that 18 does not mess with that, okay? I can check this. If you've got the fancy calculators that have your log button, just put in log base 2 of 20, because 18 plus 2 is 20, minus log base 2 of 10, and it should give you a 1. We're doing 15 log base 6 of 2 plus log base 6 of negative 5x. I'm going to put those in parentheses, equals 3. Okay, well, just like the minus was the quotient rule, the plus is the product rule. So that means that you change it to 1 log base 6, but you multiply 2 and negative 5x. That gives you a negative 10x equals 3. The product rule says when there's a plus in the middle, you change it to 1 log and you multiply the 2 things next to the logs. Everybody see what I'm doing? So now we've got the exponent is right here, so we need to put it in exponential form again. So we have 6 cubed equals negative 10x. 6 cubed, I believe, is 216, equals negative 10x. Divide by negative 10. And it's negative 21.6 equals x. When I plug that negative number into here, I still get a positive number. So it should be okay.